Alright, the first thing we're going to do is just review what you just said about the breakdown. We were doing this yesterday. We've got the energy levels, right? What'd you say makes up the energy levels?
Sublevels.
Sublevels. And then what do we say makes up the sublevels?
Orbitals.
Orbitals. Okay. There are 7 energy levels. Alright? We drew our apartment building yesterday and drew like the bottom floor was the first floor and then the top floor is the 7th floor. So it works its way from the ground up. From your notes, there were 4 sublevels, and I told you I didn't come up with the names for these, like I'm just the messenger. The sublevels are called S, P, D, and F. Your notes also tell you how many orbitals that there are for each of the sublevels. So basically, the way it works out is this. The S sublevel has 1 orbital, the P has 3, the D has 5, and the F has 7. That's how I remember this. I mean, seriously, I've done nothing more than just memorize like the lineup, that the order is S, P, D, F, and then 1, 3, 5, 7. And if somebody wants to know how many orbitals the F sublevel has, I sit there and think S, P, D, F, 1, 3, 5, 7. Okay? This would be very useful for you to be able to recall, whether it's write down, say it in your head, or whatever on the test. Okay? What we're going to look at next is the shape of the sublevels and what they look like, and then we'll look at how they fall into the apartment building, like how they fill up the floors. So if you go back to your notes over here, I had this little piece of notes right here. Let's see if it'll let me write on it. I don't think it's going to. So let me get rid of this. I'm sure there's probably a way. Alright, let's capture this one. If we look at S, P, D, and F, I have the shapes for you written out right here. S, if you're going to draw it by hand, is just going to be a circle. But in reality, it's not 2-dimensional. If it's a sphere, what does that mean? It's 3-dimensional, like a ball. It's got depth to it. The 1 orbital means there's only 1 variety of that. Like there's no other ways to draw it. There's no other ways that it exists. It's just that. Okay? The P is shaped like a dumbbell. And it says dumbbell. I think it looks more like kind of like a figure 8 turned on its side, or kind of like an infinity symbol. I mean, it's kind of like that. But there's 3 orbitals. That means there's 3 versions of this. So if you can kind of picture it, have you ever in math class seen your teachers draw like an X, Y axis, but then sometimes they'll add like a Z to show the 3rd dimension, to show that something's 3-dimensional? Have y'all ever seen that? No? It's how my little drawing on the other, like further down in the note shows it, is it adds like a 3rd dimension to it. In other words, if I use some colors, one of the dumbbells lays on the x-axis. Can you see that? Okay. Another one of the dumbbells will lie on the y-axis. Can you kind of see that now? The other one, let's make it ugly. We'll make it bright pink. The other one comes out on this z-axis, like it comes towards you as if it's shooting out of the computer screen, and then the other part of it would go back behind these in space. Can you see them in your mind, or see them up here?
Yes.
Oh, yes. There we go. Alright. So there's 3 different flavors. They exist together. They exist at the same time. I can kind of picture how that exists together. Okay, for D. D is shaped like a clover. I mean, usually what I draw for students is something, that looks kind of clover-leaf. That's a really bad clover. Don't draw a clover like I draw a clover. Maybe I'd be better off to do like 2 dumbbells, one up. There we go. That's more clover-like. But that's really oversimplified. It's kind of complicated. What matters is that there's 5 different arrangements of that, and I'm not going to draw them for you. I can show you like a graphic generated image of them in a minute. F is so stinking complicated. There's not really a word to describe it. So I write complex. Some other things put complex, but there's 7 different varieties of it. Here is someone else's better representation of these. If you look at it for a minute, do you see how this is a circle? It's a sphere. You see right here the S? It's telling you what it is. Okay, what are these 3 right there? What do you see? What letter? P. And I mean, you can kind of see the dumbbell to it if I trace it. I mean, it looks kind of like the figure 8 right there. There's 3 different versions, right? And I don't know if you can see, here's the Z-axis, the Y, and the X. They've got them on the axes to show their orientation in space. The numbers, if you're curious, have to do with the quantum mechanical model, and they have to do with the quantum numbers. I'm not concerned with you knowing P to the -1, P0, and P1. All I care that you get is that there's 3 different varieties of the P. That's the 3 orbitals. How many versions are there of D down here? There's 5. It does look kind of like a clover. They sit different ways. That doesn't look like a clover. It looks like a donut with something on top and bottom. I don't know, but there's 5 different varieties. So again, the D has 5 orbitals. Down here's F. They all look different to me. This looks like a cluster of grapes. This one looks like 6 different green spheres arranged in a circle. So does this one, but it's turned on its side. The bottom line is, how many different versions are there?
7.
There's 7. Okay? Again, memorizing this for a test, memorizing S, P, D, F, and then 1, 3, 5, and 7 is probably the easiest way. You do need to be able to tell me the shapes. I do want you to know that the S is a sphere and P is a dumbbell and that D is kind of clover-like and F is a hot mess. Okay? Okay. So now where do we go from here? Well, we need to figure out how all of this fits into the atom itself, like how it all fits in there together. From middle school or from physical science, if you took it, you were probably taught in physical science these, well, you weren't taught this right here, but you were probably taught in physical science this little piece at the bottom. Do you remember doing that? Or in middle school when you did Bohr diagrams, when you did the rings? Like in middle school you had to do you had to do the rings and you put 2 dots on the first ring, and then you had to know that you could put up to 8 dots on the second ring. Do y'all remember this?
Yes.
Okay, so a couple people were taught something, and it won't let me click that. So how you got that from middle school, the 2, the 8, the 18, and the 32, it comes from this up here. One of the things that you need to know is that orbitals can hold no more than what? 2 electrons. It doesn't say that it has to have 2, so they can have 1 or they can have none, but at most you can put 2 electrons in them. Okay, y'all, I don't memorize this set of numbers. I simply do the math in my head. If I know that S has 1 orbital and 2 electrons can go in it, then basically I just think in my head 1 times 2 is 2. The S sublevel can hold 2 electrons. If I know that P has 3 orbitals, then that means to me 3 times 2 is 6. The D has 5 orbitals. Well, each of those orbitals can still hold 2 electrons. Well, then that's 10 electrons that can go there. The F has 7 orbitals, and 7 times 2 each is 14. That's how I know that it holds 14 electrons. I memorize this right here, if I can draw that straight. I memorize this piece, and then I work this out in my head because I know this rule right here. You need to know that, okay? You need to be able to know how many electrons can go in each of the sublevels. All right, you have questions at this point? No? Okay, we're going to pause for a second and do some practice.